Hey guys, welcome to my channel Code with Kai, and topic for today is Leetcode number 154, find minimum in rotated sorted array 2. So we have already discussed the part 1 of this question in video number 8. So this is video number 10. If you want part 1, you can refer that. So let's just get started. Let's read the problem statement first. So we are given an rotated array that is rotated between 1 and n times, and this might become something like this. So I see 4 and 4, so the duplicates are there. Given a sorted array that may contain duplicates, return the minimum element in the array. So we are given this array and we want to find out what is the lowest element in it. So, and it can contain duplicate as well. Okay, so this is the array, and this we can return 0 as answer for this. Okay, what about the next one? So all elements are same, so we can return simply 4 as the answer. What about this? So the lowest element in this is 1, so we can return 1 as the answer. So hey guys, so let's take example number 1 and understand how it works. So I have starting index and ending index pointing at 0 and 5. So I've plotted a graph which has a starting index and ending index pointing at 0 and 5. I have drawn value index graph already. So let's understand that. Let's calculate mid first. What is my mid? S plus E by 2. That is going to be 0 plus 5 by 2. The answer is going to be 2. So where is my mid pointing? My mid is pointing at the second index. So let me draw where the mid is pointing. The mid is pointing right here. Now if you take a look carefully between relation between mid and index, if my mid is less than E, okay, and this array is rotated, that means after mid, if mid is low, then there will be a peak or there will be normal line like this. Okay, if the values are going to be after 2, the values are going to be either 2 2 2 2 2, or the values are going to keep increasing since it's a rotated sorted array. 6 4 5 like that, dot dot dot, it will go. Okay, if the array of mid is smaller, that means the higher number is on the right side. Okay, we are pretty sure the higher number is on the right side. That means the mid is the lowest number we can have at this point. So if you want to find the minimum, and the lowest number we can have is on the mid itself, so I can exclude this right side entirely, and I can place the end pointer that we had, place the end pointer right here. Okay, that means if array of mid is smaller than array of E, okay, that means I can exclude the right side. I can say end is equal to mid. So let's just find the mid again now. What is my mid? My mid is going to be, where is my S pointing? S is pointing at 0. Let me clear out the mid calculation. My end is pointing at 2. Okay, so this part has been excluded. My end pointer has moved right here. Okay, what is my starting index? 0. What is my ending index? 2. Divided by 2, the answer is going to be 1. So this is where the mid is going to point. Okay, and in the graph, this is where the mid is going to point. Again, I'm going to ask a simple question. What is the relation between array of mid and array of end? Is array of mid smaller than array of end? The answer is yes, it is still smaller. That means right side value can never be my answer. Okay, since mid is smaller, so how can right be my answer? So I'm going to exclude the right again. So this is where the exclusion part comes in. So I'm going to move end to mid. So this is where the mid was. So I'm going to place the mid right here. So I'm going to place the end pointer right here. Sorry. So in terms of this, I'm going to place it right here. The end is going to point to mid. Now I'm going to again calculate mid. What is my mid? My mid is going to be S plus E by 2. So what is my S? S is 0. What is my E? It is going to be the first index by 2. The answer is going to be 0. So this is where the mid is going to point now. The new mid. Let me remove the old mid. Okay. So let me ask the same question again. Is array of mid smaller than array of end? That is my mid smaller than array of end? The answer is no. Okay, and if it is not, if array of mid is greater than array of end, that means the array must be going down, right? That is the only plausible explanation. Okay, the array of mid must be higher, and whatever is at the array of end must be at the lower index. Okay, so this mid can never be my answer. Whatever there is at mid can never be my answer. This can never be my answer, or whatever is at the left of mid can never be my answer. Since we already know the lowest element at this point is at the ending index, so I can eliminate the left side of this, and I can move the starting index to mid plus 1. So this is where the starting index will go now. So otherwise I'm going to do a simple comparison again. Array of mid is greater than array of end. In that case, I'm going to move my starting index to mid plus 1. Okay, and we are going to do this until while s is less than e. Okay, I'm going to do this iteration while s is less than equal to e. Okay, let me write this. While s is less than equal to e. Why not s less than equal to e? Why not we have equal sign? Okay, that I'll answer later. So this is it for the example, this example. So they both are pointing at the lowest element now, and we can return that element. So let's just take a look at example number 2, where I have set the starting index and ending index, and I have calculated mid, and I got mid as 2. Okay, so I've pointed it accordingly. Now I'm going to ask a simple question. What if my array of mid and array of end are same? What if whatever is at array of mid, that is at 5, and whatever is at end, they both are at same? Okay, let's understand this scenario. So what I'm saying is, I'm at this point and the answer is 5. I'm at this point, the value is still 5. Okay, and can I tell if the array is rotated at this point? With these two information, I can never tell if the array is rotated. Why? Because at this point my array can go down. Okay, my array can go down, and or it can stay same, in this case, but or it can go down and bounce back. Okay, so I cannot tell if the array was rotated at this point. Okay, so and there is one more thing about this. uh, what if this was my this is since this is my e and the value is 5, and this is my mid, the value is 5, and we want to find the lowest point. Okay, so the mini I can say that this might be my lowest point, but this e can never be my lowest point. Okay, if the values are staying same, this can never be my lowest point. So I can exclude this out, and I can move it to e minus 1. Okay, I can move e to the previous index. Why? Because I can be very sure that on the right side my answer cannot lie, because that is not my lowest point. Okay, since they both are same, I can actually exclude the right side as the answer. If this was actually my answer, I will not miss the answer, because in the mid itself, or again I'm having the value of 5. Okay, to sum up, I can say that uh, when this condition and this condition fails, okay, that means array of mid and array of e both are same. That means I have to do e minus minus at that point. So I can take e and move it right here. Okay, and if we find mid at this point, we will again have the mid as, so this is going to be eliminated. So we have 0 1 0 1. So this is going to be, let's calculate mid again. 0 plus what is the end, and is going to be 4 by 2. The answer is going to be 2. So this is where the mid is pointing. So now again, mid and end both are same. So I'm pretty sure this can never be my answer. So I'm going to remove mid and move the mid to e minus 1. So again, this condition is going to execute it. Okay, and at this point I'm going to say s is equal to mid plus 1. What is my s? 0. What is my mid? 3 divided by 2. The answer is going to be 1. So this is where the new mid will point. Okay, at 1 the new mid will point. This is where the new mid will point. So I'm going to ask it a symbol. Ask it, is my array of mid less than array of e? Okay, so what is my mid? My mid is 5. Is 5 less than 2, whatever is at e? The answer is no. Okay, that means is array of mid greater than array of e? The answer is yes. In that case, this left side can never be my answer, so I'm going to take the s pointer and move to mid plus 1. So this is where the s will move. Okay, and this whole thing will be excluded. Then I'll calculate mid again. What is my mid? Okay, my mid is going to be, where is the s pointing? S is pointing at 2, E is pointing at 3. The answer is going to be 2. So this is where the E is this is where the mid is pointing. Again, I'm going to ask same thing. What is the relation between array of mid and E? So I can see that array of mid is greater than array of E. Okay, so this will be executed and the s will be pointing to mid plus 1. So this s can never be the answer. It's going to point to right here. And as soon as I have s and e both are pointing at say a same location, my binary search is going to stop. So let's just discuss the time complexity of this solution. So I have the array as 2, 4, 5. Then again I have 2, 2, 2. This was the array. In the average case, it will take log n. It will take log n time. But in the case where we have array like this, okay, since you're doing e minus minus, and this is the starting index, this is the mid, this is the ending index, this is the mid. When we do not know if when e and mid matches, then I'm going to do e minus minus, right? So e minus minus, then again, since they all are same, the mid and e are always going to be the same. So in that case, I'm just moving one step at a time. So due to that reason, uh, the worst case might be O of n, since I am actually trimming down my space from right to left. Okay, so on an average case, the time complexity of the solution is log n, but on the worst case part, the solution is O of n. Okay, and do we require extra space? No. So the final time complexity is O of n, and the space complexity for the solution is 1. Okay, that's it for the explanation part. Let's just go to the coding and finish the code. So let's start with the code. I have int s is equal to 0, int e is equal to nums dot size minus 1, while s is less than e. Okay, I'm going to do int mid is equal to s plus e minus s by 2, why if array of mid is greater than array of e, my answer can never lie on the left side. S is equal to mid plus 1. Else if array of mid is less than array of e, the end pointer can be my answer since the graph is going up at that point. Okay, so the lowest point will be at the mid. So end is equal to mid. Then I'm going to do else. They both are same. In that case, I'm going to do e minus minus. And outside, I'm going to return array of s as the answer. You can return array of e as well. So one more question that you might have is, why are we looping till s less than e? That is, the reason is we are doing e minus minus at this point, right? So that is the reason why we are saying s less than e. Okay, this guarantees that doing s less than e guarantees that when the loop ends, okay, so s and e both will be pointing at the same index. Let me show you that. E and E and L. Let's run the code. Getting an error. Let's replace that with nums. Alpha occurrences. So let's run this code. Yeah, so let's see the test result. So this is where the S and E are pointing. But if I do S is less than equal to E and if I run the code, so the S and E will be different at this point. So yeah, the E goes to -1. That is the reason why we are writing S less than E and not S less than equal to E, since we are doing E minus minus at that point. Okay, so one extra comparison will be done if we do equal sign. So let's just submit this code out. Yeah, so it passes all test cases and beats 100%. So that is it for the video. If you like, kindly subscribe and share the video. Bye.